Welcome to this lesson on percents. Today we're going to use this silly parrot family to kind of give us a topic, so to speak, when we talk about percents. And we're going to learn a little bit about this family as we go. Really, the birds have nothing to do with it. They're just something silly to look at and work with. So when we're working on this, we're going to understand that a percent is a representation of a whole. So it's a representation of a part of a whole. And then we're going to figure out how to use that numerical value of the percent and how we're going to find that, or how we're going to use that when given a percent and a part to find the whole, or how to find the percent when given the part and the whole. So if you break it down, a percent is a part of the whole. So when you have two out of the three things here, so if I have the percent and I have the part, I can find the whole. If I don't know the percent, but I know the part and the whole, I can find it. Or if I have the percent and the whole, I can use those to find the part. I just have to be able to represent each of those things. And I also need to understand that the percent in this case, it's not a number. Right? So when we talk about this next problem, we're looking at Brother Pat and his friends. And we have 10%. 10% does not mean 10. There is one case where it might mean 10, but it's not always going to be 10. Okay, 10% is a representation. It's saying that, okay, well, if I were to take all of this and make it out of 100, it would be 10%. But because not everything is out of 100, that would make life way too easy for us. So because everything isn't out of 100, we turn it into a percent to make it a little bit easier to conceptualize or to kind of visualize and understand. Right? And we'll kind of talk about that as we go along, and we are going to draw some diagrams to help us better understand what's actually happening here. So let's look at the problem. We want to know how many do not have blue feathers. It's important to note, do not have blue feathers. All right, so let's look at the problem and see if we can find important information. So 10% of Brother Pat's friends have blue feathers. Okay, if he has 300 friends, how many have blue feathers? So we want to know both. We want to know how many have blue feathers and how many don't have blue feathers. Well, that's easy because if you find one, you should be able to find the other. So 10% is important because I know 10% of them have blue feathers, and 300 is important because we talked about we want a percent, and a percent is part of a whole. In this case, the whole is 300 because that's all of Brother Pat's friends. Right? So it's also nice to in here say, okay, this is the percent, which is usually fairly obvious because it's indicated with the percentage sign, and then to decide, is 300 the part or the whole? Well, 300 is how many friends he has, so this is the whole. All right, so let's look at this as a picture. So right now we're not really focusing on the math behind it, we're focusing on the understanding of what 10% means, because it is a little confusing. So you have to remember that percent means per 100. So if it was 10%, it means 10 per 100. So for every 100, 10 of them have blue feathers. So I'm going to use the highlighter tool to make this a little easier. So in this group of 100, there's 10 that have blue feathers. In this group of 100, there's 10 with blue feathers. And in this group of 100, there's 10 with blue feathers. So 10% doesn't mean 10 because there's 10 in this group of 100, and jumping ahead of myself here, there's 10 in this group that have 100, and there's 10 in this group that have 100, or that have blue feathers. 10 in this group of 100 that have blue feathers. There we go. So if you look at it this way, if you're able to break it into hundreds, which because this is 300 we can say, okay, out of this 100 I take 10, out of this one I take 10, and this one I take 10. So I know that 30 of Pete's friends have blue feathers. And then I also know, well, I know how many there are total. I know 30 have blue feathers. So if I do the subtraction, I know that 270 do not have blue feathers. Right? So a big part of what I want you guys to understand is what actually is going on here. So what does this actually mean? What does 10% actually represent? Like I said before, it didn't represent 10. It represented 10 if this were 100, but this is 300. Another way to use this is using a different diagram. Okay, and this, some people call it a double bar diagram, double line graph. We're just going to go ahead and call it our percentage diagram, just to make it easier for our class. So we have the top, which is going to it's going to be a number line of our percents, and we have the bottom, which is going to be the number line of our number of birds. Here is 0. Here is 0. That's the easiest part of this to do, because you know if you have 0%, you have 0 total. Now, percentage-wise, it's always 0 to 100. Okay, we're not working with percentages bigger than 100% because right now we're just talking about what percentages actually mean and how to use them. We're not worried about over 100% at this point. Now, I know that 100% of the birds, so if 100% of the birds have blue feathers, that would mean all of the birds had blue feathers. So that would be my whole. So 100% is equal to my whole. So if we said 100% of his friends have blue feathers, we would say, well, duh, 300 have blue feathers. So in this case, 100% is equal to 300. Now we need to look for something that will give us 10 up here because we're looking for 10%. So we need to look for something that will give us 10 up here, but also get us to 300 down here. Both 300 and 10, if you count by tens, you can get to 10, and if you count by 10, you can get to 300. And we have to include this 100%, the 100% up here. If you count by 10, you can get to 100. This isn't always going to be the case. Sometimes you're going to have to count by 20s, 5s, 2s, whatever the case may be, but you have to find a number that is going to get you the percentage up here. It's going to count to the 100%, and it's also going to be a factor of 300. Right? So we decided that 10 will work because 10 is a factor of 300, and it's what we're trying to get to, and we can count to. So basically, is it a factor of 300 and 100, or your whole and 100? So let's go ahead and count by tens. We have 10, this is the percent, 20, 30, 40, 50, 60, 70, 80, 90, 100. And you can just go ahead and you don't have to put all of them. Okay, you can start skipping and going every other one as long as you remember that the middle ones are worth 70 and so on. All right, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Perfect. Now, I took this because I had to count by tens to get to 100. I wasn't trying to get to 300. I was trying to get to 100. Now I have to say, since I did that, I have 300 and I put them into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. So I take that 300 and I divide it by 10, which I know, just in case I don't, I just do the math, gives me 30. So that tells me that each of these groups is worth 30. So 30, 60, 90, 120, 180, oops, forgot 210, 240, what did I forget here? 30, 60, 90. Oh my goodness, I forgot 150. I started counting by 60s. Too many numbers. There we go. 210, 240, 270. Okay, so again, you got to be careful because even we make mistakes in saying, okay, 30, 60, 90, and then all of a sudden I started counting by 60s. Why? I don't know. So just make sure that you're going through and double checking your work and saying, nope, I made a mistake. I'm going to go ahead and erase and fix that and make sure I know that these numbers are actually correct. So now I know that 10% is equal to 30, and I used my diagram to help me prove that. And then I can also look and say, oh, well, if I wanted 20%, that's equal to 60. I can also look and say that since I wanted to know how many have, so since have was 10%, I know that don't have is equal to 90%. So I could go here and say, okay, 90% is right here. What is that equal to? And it's equal to 270. So I wouldn't even have had to do any subtracting there if I didn't want to. I could just use my diagram to match it up. Hey, again, this is a visual of what's going on. So 10% didn't equal 10 because it wasn't out of 100, it was out of 300. 10% to us, you can look at it and say, okay, 10%, that's going to be kind of it should be a smaller number, much smaller number than 300. And then what I can do is say, okay, I can use that percent to help me find that missing piece. Again, right now we're conceptualizing and we will get to the math behind it. And I do want you to be able to do the math, but you also have to understand what it means. Okay, so 10% out of every 100. This is exactly what we had gone through before, just in case you missed it and want to make sure to get it written down. Now, we have 45% of Mama Pat's hats that are blue, and she has 20 hats. How many are blue and how many are not blue? We're going to go ahead and we're going to take that not part out because you should be able to easily figure those pieces out. So we're going to go ahead and take that out for this one. And we're going to look at drawing a picture again here. Now, here's the thing. The total in this case, so we want to know how many hats are blue. They really like blue, don't they? And it's important to know that she has 20 hats and 45% are blue. In this case, this is the whole. This is her total amount of hats. And you know that because it says if she has 20 hats. If it said if she has 20 hats that are blue, that would be our part. But in this case, 20 is the whole, and obviously 45 is the percent. Now, the problem here is we can't draw something that's out of 100 because this isn't a 100 number. This is a 10. Okay, so in this case, that first picture that we drew isn't going to really help us out much. This is where our percent diagram is going to be much more helpful. All right, so what I actually want you to do is I actually want you to try to set this one up on your own. You don't have to do any of the bars in the middle. I want you to set up your numbers, so your label, what goes here, here, and here. And when you come back, check your work. Okay, so I have percent on top. Now, you could put percent on the bottom. It doesn't matter as long as you stay consistent. And 0% would be down here. And 100% would be down here because this would be, and then if you look at it, all of this right here, this whole thing is Mama Patty's hats. So her hats, 0% of the hats would be 0, and 100% of the hats would be 20. Now I have to look for something that is a factor of 120 and will also, when you count by it, get you to 45. Well, 20 and 100 are both divisible by 20, but if I count by 20s, so 20, 40, 60, I don't get to 25, so that won't work. 10 and 20 are both divisible by 10, so 10 is a factor, so 10, 20, 30, 40, 50, but it doesn't get me to 45, so that won't work. 5 is also a factor of both of these. And I know that if I count by 5 and to spare us all that counting, I know I can get to 45. So what I'm going to do here is I'm going to count by 5s. Now remember, this is for the percentages because I'm working on getting to 45%. If this were 45 hats, we would be working that part on the bottom. All right, so we have 5, 10, 15, 20, 25, 30. I'm going to put 30 here so I don't forget. 35, 40, 45, and I'm going to mark the 45 because I know I'm going to work with that one. 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Now, is my diagram perfect and absolutely equal? No. It should be close to equal, but it does not need to be perfect because I understand that you're human and some of you might be able to draw fantastically and draw pretty close to equal. Majority of us, though, aren't that talented, as you very well can see. So here, I know that I took this and I broke it into 20 pieces because I know 100 divided by 5 is 20. So then I know that each of these is worth. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oops, that should be 20. Then I know that each of these has to be worth 1. So here you have 1, 2, 3 hats, 4 hats, 5 hats, 6 hats, and actually I don't think we lined this up right. I think we put too many at the end. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. One too many. So notice, I want you to see that we can make a lot of mistakes when we're drawing these. And the beautiful part is there are these wonderful things called erasers because we're supposed to make mistakes. And this is where you have to be really careful because it is hard to see all the different boxes and make sure that you have the right amount of numbers. So if you do make a mistake, don't get frustrated and go through and erase everything. Just erase that last little part and fix where your mistake is. If you don't have to start all over, don't. All right, and now we know here that 45% is equal to 9. So 9 of her hats are blue. Right? So it's not that 45 are blue because that'd be kind of hard out of 20. 45% just tells you, well, it's not going to be half because I know half of 20 is 10 and 45%, half is equal to 55% and 45% is less than 50. So you can use all these ideas and understandings to help you kind of guess at your answer and know that, well, half would be 10, so I know my answer should be smaller than 10, and in this case it was. Again, I know that this is a little bit tough and it's tricky and we're thinking, why do we have to do these drawings? Because you have to be able to understand what's going on. You have to be able to visualize what the percentage is and what it means. Do I expect you to use this in everyday life? Absolutely not. I expect you to use the math of it, but if you don't understand what's going on, and some of us need that visual representation, it is not going to make sense. So actually what we're going to do is we're going to stop here and I'm going to split this into 2 parts because of the fact that I want you to really understand what's going on before we dive into the math of it. So I know you already have this part, but we're going to go ahead and, like I said, stop here. So hold on to your notes for this. And I want you to take a look at that first you try problem, which talks about Papa Pete. And I want you to try this one. So try the Papa Pete problem, and I want you to use the percent diagram. Okay, I know in the you try it says, use proportions and this and that. No, I just want you to draw your percent diagram. Okay, because I really want to make sure that we're understanding what's actually going on here and what visually is happening. As always, if you have questions, please make sure to write them down or email me with them. And especially with this lesson, please make sure that if you have questions, don't hesitate to ask, because this is a harder concept. It's a little bit more abstract when you think about it. So I guarantee you that other people are going to have the same question as well.